All right, this is part 2 of chapter 12 review. All right, so we're just going to walk through the rest of the lesson. So that was lesson 1. All right, lesson 2. You've got to be able to write an augmented matrix and know if you have an augmented matrix, can you then write the equations that go with it? So, right, it's just x, y, z equals the number, like number 17. Write the linear equations. That would be 2x plus 6y equals 16 and 2x plus 3y equals 7. Got it? Mm-hmm. Pretty easy, right? All right, so that's what lesson 2 was about. Can you look at equations, write an augmented matrix? Can you take an augmented matrix and go back and write the equations? Lesson 3. When can we add and subtract matrices? Yep.
If it's like a 3 by 2 and then a 2 by 2.
Add or subtract. Add or subtract. That is a difference. They have to be the exact same. To add and subtract matrices, the matrices have to be the exact same. If it's a 3 by 3, it has to be 3 by 3. If it's a 2 by 3, it has to be a 2 by 3. Okay? Now, multiplying. That's when it matters. So, Natalie, what were you saying? If the first one is a
3 by 2, and then the second one is a 2 by 2, then it can be multiplied because the middle numbers are the same.
That's right. The columns in the first one have to equal the rows in the second one. Okay, and what is the resultant matrix? The outside. You're going to end up with a 3 by 2. All right? How do we find the inverse of a matrix?
You plug the matrix in and then you raise it to the -1.
Correct. Plug it in, raise it to the -1. Does every matrix have an inverse?
No.
No, they do not. All right, how do we solve matrices using inverses? Like number 35. Let's work number 35 in the review. So now we're on lesson 4. Let's do it. 35, bottom of page 836. So what do I put in? Somebody tell me. Okay, I'm doing it, but tell me. How do I solve using inverses?
You have to make it an augmented matrix.
Okay. What do I put in this augmented matrix?
1, -2, 3, 4, 2, 1.
Are you on 35?
Yeah.
Oh, look. There we go. Forget 35 because that's 12.4. Okay. So what do you put in for 35? 1?
1, -2, 3, 4.
We're not putting in 4 when we use inverse.
Oh,
Right?
right.
We're not putting in what's on the other side of the equal sign. So we do a 3 by 3, which is just the coefficients. And then we do a 3 by 1, which are just the constants. Right? And then, so we have a 3 by 3 and a 3 by 1. We have a 3 by 3 and a 3 by 1. We can multiply them, but we're going to do the inverse, right? We're going to do the inverse of the first one times the second one. We're going to end up with a 3 by 1, but that's our solutions. All right?
So wait, you would do the first one to the -1 times.
Times the second one.
Okay.
Yep. And what do you get for number 35?
432.
432. That's what I got. X equals 4, Y equals 3, Z equals 2. All right, and that's through 38. Then I have 41 through 43 and 45. These have to be solved either using substitution or elimination. You can't use these. You cannot solve anything that's squared in a matrix. Okay? Any equation to the second degree cannot be solved in a matrix. So these you're going to solve algebraically by using substitution or elimination in lesson 5. Or you're going to plug them into y sub 1, y sub 2, see where they intersect. Okay? Yes?
When I did it, I got 553.
All right, let's look at your matrix.